Good morning, everyone. And we're going to begin our next session. My name is Michael Young. I am the Associate Dean for Diversity, Equity, and Inclusion and Associate Professor at Carnegie Mellon University. And I have the honor and privilege of introducing our speaker today in this session. So I'm gonna begin, and this may take a moment. I hope I have enough time to say all the wonderful things about our speaker that need to be said. So this morning's talk is going to be given by Dr. Pamela E. Harris. And Dr. Harris began her journey in the professorate at Milwaukee Technical College, where she received associate degrees, and she completed her bachelor's degree at Marquette University, and master's and 2012 PhD at the University of Milwaukee, Wisconsin. Dr. Harris then went on to be a Davies Research Fellow at the United States Military Academy until she joined the faculty of Williams College in 2016. And I am reminded quite often that I also interviewed for that same job in that same year. In 2022, she returned home to the University of Wisconsin-Milwaukee, where she currently serves as a full professor of mathematics. Dr. Harris's primary research interest is in algebraic combinatorics with a focus on vector parking functions. She also studies number theory, graph theory, and mathematics education. Dr. Harris has been the recipient of many awards and fellowships, such as the 2019 Mathematical Association of America Henry L. Alger Award for Distinguished Teaching, the 2019 Council of Undergraduate Research Faculty Mentor Award, the 2012 Deborah and Franklin Hymo Award for Distinguished College or University Teaching of Mathematics. She's been named a Karen Edge Fellow in 2020, a Fellow of the American Math Society in 2022, and a Fellow of the Association of Women in Mathematics in 2022 as well. Dr. Harris is a co-author of the book series Asked and Answered, Dialogues on Advocating for Students of Color in Mathematics. She is the co-host of the podcast Mathematically Uncensored. She is a co-founder of the online platform Lathisms. She is a strong advocate, a distinguished teacher, a proven leader, a very, very supportive mentor, and a remarkable mother. She is a prolific mathematician and someone I have the honor of being able to call colleague, collaborator, and friend. And in the words of Dr. Eris Winger, she is a true treasure to the discipline of mathematics. Please help me in welcoming Dr. Harris to this stage.
You did good. You did good. Wowza, thank you, Michael Young. The honor of working with him, you have no idea. He's just a fantastic mentor. So I'm really thankful for him. All right, so you are here to hear me tell you about this myth in mathematics and mathematics education. And maybe from the abstract of the talk, you kind of already know what I'm gonna say to you. It's not gonna be a surprise, but I wanna start with a story. So I wanna tell you about the first day that I stood in front of a classroom as the instructor of record for a class. So this was intermediate algebra. And maybe you don't teach this at your university, but intermediate algebra is basically the class that is a prerequisite for college algebra. And some of my graduate students currently teach this course, so I too stood in the front of the room. And the funny thing, maybe funny now in retrospect, but I was handed a textbook for the course, an old syllabus, and then I got told when to show up, and that was basically it. And so I was terrified. There was absolutely no training whatsoever. And so I remember thinking, well, I can't show up too early because I don't know what they're gonna ask me. I probably don't know the answer, like where the registrar is, or like, are they in the classroom that they're supposed to be in? So I was just like, I'm just gonna show up with like just enough time to like set my books down and then look up and start talking to them. And I remember this is what it felt like. People just staring at me, and all of a sudden I was supposed to know stuff. And not only know it well enough, but somehow be able to teach it to them. And standing here today, I don't feel this that I felt then. That like just wobbly feeling of your legs where you feel like you might actually pass out. I felt sick that all of a sudden I was responsible for the learning of these like people in front of me who had paid quite a bit of tuition. Even though UWM is quite accessible, it's still a lot of money. People are sending their children and making huge sacrifices. And here I am as a 22-year-old, somehow ready to impart wisdom upon them. And the reality is that I have absolutely no business being in that classroom. Like, I had no training, no one was watching me. I could have just been teaching them utter nonsense, and I don't think I would have been fired, okay? But we all know that it didn't actually matter, right? Like, it literally didn't matter that I had no training and no real reason to be there. Because you know what I came armed with? A bachelor's of math. Okay? I was like, yeah, somehow at that point you make it and you're trusted enough with teaching your peers. And here's the thing, I'm not the only one. So there's about 146,000 graduate students teaching in this country. They are responsible for their discussion sections, the grading, sometimes even the mentoring of other people. They're the ones that are writing tons of letters of recommendation later for those students. Are we surprised about that? Where's my graduate students at? Thank you for all that you do for those students. Now, like I said, I had very, very little training as a graduate teaching assistant. And so what did I do? I tried to mimic sort of what I thought was like good pedagogy. I had no idea. I thought you just had to be in front of a classroom and be entertaining, make them laugh once in a while. Who cares if they learned anything, as long as I put on a good show. And it feels like for a very long time, that's exactly what education was supposed to look like. It took me a very long time to realize that that's not the quality of a good educator. It is not sitting in front of a classroom and making them feel good. It's actually quite the opposite. The more discomfort that they feel is probably the better of a teacher you're being. I also never got watched. Maybe one time in all of those years, somebody actually watched me. Sound familiar? Okay. Nobody's really checking up on us. So what did I do? Well, I relied very heavily on all of my peers. I had tons of really fantastic graduate TA peers, and most of the time there was somebody, who was maybe a year ahead of me, who had a really great syllabus or a really wonderful activity or a quiz that maybe not 30% of the students failed. So I got to lean in on that, and I'm super thankful for all of their feedback and suggestions. So I tried to look up data nationally to figure out how many of current graduate teaching assistants are actually getting any training, and I actually found none. Like, I don't know that we know who's actually getting training, let alone whether that's good training. Okay, because I know of some places that claim to train you. Maybe they put you through a semester-long course. Maybe you have, you meet once a week and you discuss Bloomberg's taxonomy of the learner, and then they're like, yeah, they should not be hungry. And then you go and teach math. And so the quality and the depth of that training, I don't know what that looks like, honestly. And maybe there are some places that are setting the bar, and I actually can't point you to them. Okay, but what do we know? Well, we do know that these graduate teaching assistants have a deep and lasting impact on the work that they do. And in fact, there's this wonderful article that I was reading in preparation for the talk, and one of the things that the authors argue is that we need to continue to support our graduate teaching assistants. Okay, they've gone through their math career, and maybe they've been the ones that excelled. And maybe math came easier to them at that stage, and now they have to teach new students, and they need to figure out how to support those students, especially when it comes to student thinking. Like, what does student thinking look like? Why are they making that mistake? What were they thinking, right? Like, that takes some skill to develop. And so we are a long way from remedying this challenge. But here's what I'm gonna do. So I pointed a problem, and I'm just gonna say, forget about it. Let's just pretend we don't care about this training, and let's talk about the culture of math. Okay, so here's, a similar of a quote of things that I got told when I was an undergraduate. So a lot of my jobs as an undergraduate, once I decided the math was the thing that I was supposed to do, only because I was encouraged to do math, I would work at the tutoring center. And of course I did it because it was the best paying job. And it always felt like I was learning. I was like, ooh, I get to explain that to somebody. And when they get that little moment where they get it, and I feel like I contributed to them having that moment, right? Like that was so pleasant. And I remember people saying things to me like, well, yeah, sure, you can tutor, but really you should be focusing on your own classwork. Absolutely focus on your own classwork before you help anybody else. But now I think I was learning so much more. I was so much better prepared for my own coursework because I was doing tutoring. So that happened as an undergrad. And then as a graduate student, you often hear these quotes like, oh, any time that you spend on any teaching activity is taking you away from your research, and you need to graduate. So don't do that. Okay, fine, just do it mediocrely, just so that you're an okay teacher. Because at the end of the day, really what you're being paid for as a graduate student is for you to do research and get your degree. We've heard this before? Have we said this before? I've said this many, many times to people that are in the audience. And it is my shame to have said that to them, because instead I should be encouraging them to be their best self. And so I just want to publicly apologize to students like Kim Harry, Alex Moon, Kimberly Hadaway, for ever telling you not to prioritize this. Because the way that you impact other people matters, and those students matter. And so I am sorry. I will do better. So now what happens during the postdoc years? Well, I got told things like, teaching well is not the thing that's gonna get you a job. The thing that's gonna get you a job and set you apart is your publications. It's your research track record. And I am not saying this might not be true, because again, what am I arguing about? I'm arguing that this is the culture we have built in mathematics. So, let me tell you this one story. I returned to Marquette University one summer as a postdoc, and I was teaching in a trio program. And it was one of those experiences where I actually have in front of me a group of students that looks just like me. First generation, marginalized along some axes, and I am so excited to get to work with them. And I remember being in the hallway, because they lent me an office, and I was, in the math department, very excited. And, one of my mentors there came up to me and said, oh, what are you doing here? I didn't know you were back. And I was like, oh, I'm working in this trio program. It's been really lovely. I get to work with these students, and I want to inspire them. I want them to know that they can be mathematicians. I want them to know they can be mathematicians, because it's my first time returning with a PhD at hand, so I feel really proud. And he said something to me like, well, to show them they can be mathematicians, you shouldn't be teaching them, you should be doing research. And I thought, I will show them. I will do research, but I also will teach them. I don't know that many things changed during the tenure track years, especially when I was starting. So I remember being told as I was interviewing for jobs to always ask the question, and in fact, I've told a few people here when I've had coffee, make sure you ask them, the last person that didn't get tenure, why didn't they get tenure? Right? This tends to be a common piece of advice us older people tell the younger people to ask, so that you kind of can gauge what is important to them. And almost always the reason why somebody didn't get tenure is because of their research. So that is absolutely a priority. I also got told early on, listen, yeah, they care about teaching, but if your research is amazing, you won't get fired. And I was like, oh, okay. And in fact, like Michael just mentioned, I just went through promotion. And it was very clear to me that, and it was written even in the documents, right? The expectation to become a full professor means that you're an internationally recognized researcher. Nothing to do about teaching. In fact, during the process of putting the packet together, we realized that no one had ever seen me teach. So then, okay, hurry up, somebody go in and check that she's not causing damage. Hopefully, I don't think I was. But here's the clear message that I was getting, that really the only thing that mattered was my research, and that absolutely anything that I did that was not my research was detracting from my research. That was the message I got, or at least that's how I was interpreting this. I also got the message that if I did spend time being a good teacher, that was not gonna be valuable. Like, that was an extra thing. That was my hobby. That was the thing I did on the side. And then that meant that I couldn't be good at both. All right, cue in the symmetric difference. That's exactly what it felt like to me. It felt like to me like we had these two sets of things that are supposed to be part of the responsibility of my job as a professor, being an educator and being a researcher, but I was getting the clear messaging that really the only one that mattered was the research part. And so, well, that's stressful, to be on a job and getting this message while every day I'm going to teach and I'm looking at these students and somehow I have to tell them that they matter, but really for my promotion and my success, they didn't. So there's this huge misconception, this myth, that being a strong math researcher means that you neglect teaching. Okay, then there's also the other part of that, which is being a great teacher somehow makes you less math research capable. But the reality is that these two things are super intertwined. Being good at one makes you good at the other. They play nicely together. They're not in conflict. And so I want us to remember that. That's the part that for me is important. And so not only that, there's also other things that we're fighting, maybe even outside of just our math community, maybe just in society in general. There's this huge cultural bias that the good researchers are super inept, right? Don't we have like some joke about how do you tell who an extroverted mathematician is? They look at your shoes rather than their shoes, right? Like there's all this bias in our society about who is a good researcher. And then there's also this perceived time conflict. Again, that anything and everything that takes you away from your research means you're not gonna be good at your research. Okay, let me tell you a little bit about how I think of this kind of culture of research mathematics. So certainly we value breakthroughs in theoretical and applied mathematics, and the way that we advance in our career often relies on publishing in prestigious journals, getting your grant funding from NSF and other such agencies, and then producing some impactful results, maybe getting invited to give a talk at JMM on the big stage. Oh, probably not, because this is an education talk. And then community norms. We celebrate mathematicians sometimes to the extreme and make it seem like research output is really the only worthy thing in our fields. Okay? I see some head nods. But now let me tell you a little bit about what I see when I work with all my education friends. So many of the conversations that they're having is always about accessibility. How do they prioritize teaching and how they try to make things understandable? Not talking over people's heads, not giving a talk where the first 10 minutes are for everyone and the next 40 are for no one but themselves. Okay, you laugh because you've been to a few talks, I'm sure, that were like that. But also, including new people and engaging diverse learners. And also their success is not about them, it's about their students. And that to me is such a powerful message that I really, really, really love, because I feel like my success is seeing my students succeed. And so that kind of hits home. But also they recognize, and they acknowledge this very broadly, that their teaching, their mentoring, and their outreach is often gonna go undervalued. And that in spite of it going undervalued, that their work is important and they continue doing it. Okay, so then the challenge becomes, we know this, we've heard this, maybe we're even part of the problem, that research is valued over any of our teaching or education endeavors. And the painful thing is that as you go through your career, very often, if you prioritize incorrectly, you may then be feeling like you're not valuable, right? Because if you're working and doing something that you love and you believe has value, and that's not the same thing that your institution values, you're gonna get very, very clear messages that you're not good enough. But it is not true. Okay, So, of course, symmetric difference, the goal is to work at the intersection. So, part of what I feel like I have founded my career on is this premise that I'm gonna do both. I wanna be a great educator, and I wanna do great research. And so for me, it has become just like, I don't even think about it. It's just like everything I ever do is like work at this intersection. How do I teach students about research? And sometimes it's about talking about how do you read a math paper? How do you put this presentation together? And being really intentional about it. So not a one-off, but like trying to embed this into my everyday work. But also, I think a lot about accessibility. So who gets to experience doing mathematical research or learning about the research methods in our fields? And I want to talk about three things, but really I want to focus for now on the first one, which has been a major part of my life over the past few years, and this is undergraduate research experiences in math. Of course, I'll tell you a little bit about how I've been embedding research in courses, both at the undergraduate and graduate level, and then I'm gonna get us to an exercise because I'm gonna put you to work today, and we're gonna develop a research methods course together. So let me tell you about undergraduate research and some of the things that I've been experiencing and thinking about. So first off, a lot of the data and history that I'll tell you about is coming from this book that was edited by Peterson and Rubenstein, and it is a fantastic book. The first chapter, I think, really sets the premise for how we got to where we are today. So I wanted to share that with you. So this is an article by Donald O'Shea, so it's the first chapter titled Undergraduate Research and the Mathematics Profession. And they start just with the history of how universities came to be in the United States. So they talk about the 1862 Morrill Act, which established land-grant institutions. And then they talk about this kind of boom on university numbers. So we go from 563 to 977 institutions during the period of time 69 to 1899. And then they mention that at this point in time, our students who wanted to go to graduate school actually had to go to Europe to get educated. And then we fast forward to early 1900s, and there's this idea of the math research community. They weren't talking to education people. They were just like, you know what, let's experiment. Like, let's see how we can kind of do some research or mimic some research. And a professor who I will not name, you probably know why, I guess if you know, you know, teaching topology to beginning students using this method of mimicking research. Some problems came later to light. And then in the 1930s, there was a push by the Michigan section, Let's Go Midwest, from the MAA appointing this committee to create and think about the interest. How do we expand the interest of undergraduate research? And then in 1942, Griffin does this mass survey of college and university mathematics departments to figure out what kind of research experience their undergraduates are getting. And here's a quote from O'Shea, who says, that Griffin documented an impressive array of student research achievements, noted that colleges that encouraged their undergraduates to do research produced more students who went on to receive graduate degrees in mathematics, which we know, but they didn't at that time, right? So this is in the 40s. And when we look at just that first half of the century, some sectional student meetings were happening and students were going to present. So just like the poster session that happened yesterday, the two poster sessions that happened yesterday, we need two, that's how much more research we're doing. And then some mathematics departments were doing a lot of thesis. So this seemed to be the kind of activity that people were undertaking at that time. But also they noted that there was this practice of exams. And I believe, I'm just gonna say it. I think Amherst College still does this. I think they still have like a bachelor's exit exam. I see some head nods. And the way that O'Shea puts it is that this is a practice almost orthogonal to student research. Now, what happens in this post-World War II era? We see that there's a huge jump in the enrollment at colleges. So from 1960 to 1975, it triples. Institutions continue to grow in numbers. So we have this increase of 25% in the 60s, another 10% in the range of 1970 to 75. So we're seeing a boom in the number of students, a boom in the number of institutions, and we also see this dire need to get more mathematicians, to create more research scientists. So what do we do? Well, the National Science Foundation, founded in the 1950s, by Truman, they start thinking about how do we experiment and embed some research in science education. And so they start this thing they called the undergraduate research program. It was primarily in biology, chemistry, and physics. And I think the math people, we slept on this one. And it gave students the opportunity to go to these like very research active labs to actually do research with those scholars. And it was at research labs, at research institutions, even some liberal arts colleges were in that group. But again, biology, chemistry, physics were the primary drivers of that funding. And then in mathematics, what you saw was a lot more like enrichment activities. You know, like let's get together and talk a little bit about math. Sometimes there were accelerated instruction. Okay, well, you're gonna go to graduate school, so we need to like really do lots more real analysis or abstract algebra. And then some formats of what was being funded encouraged students to work together. But not all, but most. But sometimes it was this kind of competition math. So they would have more competition or challenging problems. There was in particular one program that gets mentioned, which was at Carleton College, directed by Kenneth May, which really was, I think, what we think of now as undergraduate research, really kind of pushing the limits of what is known. And in 20 years, what happened was really not much changed. Some people still had these doubts about the value and the worth of doing undergraduate research. Some quotes from this summary of resolutions from a 1961 undergraduate research and math conference, actually at Carleton. Here's what they said. They said, the aims of undergraduate research are the training and stimulation of the student, not the attainment of new results, though such bonuses will come occasionally. They also said that undergraduate research should be judged by standards different from those now employed by mathematicians. And then they acknowledged that student activity of the research type was part of a good math education. Okay. But here's the quote that we saw 20 years before that Griffin read at the 1941 summer meeting of the MAA in Chicago. It is, of course, a fair question how generally undergraduates ought to attempt mathematical research. For students who are going on to the graduate school, there is much more fundamental material to be learned as a basis for specialization that it is debatable whether time ought to be used for efforts in research. And whether a student is going on or not, one may wonder how much worthwhile research can be, sorry, I can't even like read it without wanting to punch somebody, can be accomplished with the tools available in undergraduate days. Possibly the experience of institutions which have experimented with undergraduate research projects may throw some light on these questions. Okay, so again, we're getting the clear message. We don't really know what undergraduate research is. We question whether it's even valuable to do research. Maybe instead they should just be taking harder, more advanced topics courses. And even still, with those doubts and with those questions, people continue to do research with their students, mostly through thesis. But really, it was a huge funding opportunity that they missed during those years. But cue in Joe Gallion. In 1977, he established his REU over at Duluth. It's a 10-week summer program, and it is right now the longest running REU. I don't think that has changed. I'm not claiming that they've had funding the whole time, because you'll see in a second that they couldn't have. But what happened was, this undergraduate research program that the NSF started was terminated. Because all of a sudden, we didn't have a need anymore, okay? All right, great. Yet, look at the year. So that was in 1981, they shut down that program. In 1984, this thing that's called the David Report documents a critical shortage of young people entering mathematical careers. All right, great. So now there's an issue, so we need to throw some money at it. So Congress comes through and creates a plan to counter this trend. And so now in 87, so look at how many years we missed of very talented individuals going into mathematics. In 1987, they restarted what we now have as the undergraduate research programs, these experiences. Okay, so now let me tell you where we currently are. So I just looked this up. There's 45 REU math sites that are currently funded by the NSF. Of course, math institutes like SL Math and iCERM, IPAM, among others, have their own version of these programs. I've been lucky to participate in those. And then we even have our professional societies like MAA providing some funding for folks to do this kind of work at their institutions. And so O'Shea says, indeed, one could argue that undergraduate research is now one of the features characterizing mathematical education. So here's the problem. These things are super competitive. Super competitive. So I wanted to just give you the data that I know because of the problem or the projects and programs I've been involved in. So MSRI up 2019, we got about 400 applications for 18 students. Then 2 years later, of course, pandemic happened in between. I mean, we were still in pandemic. 2021, we were virtual, but we received over 200 applications, again, for 18 students. Summer at ISERM 2023, back in person, 400 applications for 24 students. The RU in Puerto Rico, we opened applications a little bit late, so some students had already maybe found some opportunities, but we got 85 applications, a little over 85 applications for 11 students. So great, like we really want students to have these opportunities, but only some. Accessibility out the window, okay? And here's the thing that is weighing so heavily on me right now. So O'Shea says, we would do well to remember that federally funded undergraduate research disappeared in 1980, almost overnight. And we've seen this happen already. The Smith Postback program, the Carleton's Women program, no funding. Even though they have incredible track records and how much they've impacted the community with their programming. They've disappeared. Their funding has disappeared. And I don't know about you, but this might happen soon. Okay, so we have to remember these things because they have happened and they're likely to happen again. So of course the concern then becomes, we're expecting now, if students proceed onto graduate school, that they might have some research experience. That absolutely sets them apart. They're also very competitive, so maybe the students that would most benefit from these experiences no longer get them. And the funding might disappear. Okay, so then here's my proposal. We have to figure out how to further incorporate research opportunities in our curriculum. This has to be part of our standard mathematical curriculum. Not an option for the strong students, whatever that means, but it has to be embedded in the experience that these students have as undergraduates. And so I want to tell you a little bit about the things I've done and the things I hope to do, which is I've been doing this when I think about some of my non-research courses, because I run types of courses. So, well, sometimes I have to teach calculus, or sometimes I have to teach combinatorics, which tend to be the introductory courses for those students. But how do I embed some of those ideas still in there so that they have the experience of doing a little bit of research that is appropriate to them? And then, of course, I do just straight up research courses. But this new last thing is what we'll work on together in a bit, which is thinking about what are the research methods that students really need to learn about. So things like the following is what I've incorporated. So of course, just very open-ended things. Giving students options and agency in selecting something of interest and digging deep into it, right? Like figure out what are you passionate about and go read about it and then tell other people about it. So these are some of the topics that the students picked in this combinatorics class. So trends in parking functions, Rota's basis conjecture, somebody was interested in self-avoiding walks on a lattice, and then some vector partition function stuff. And that was really fun for them because the class was small, they got to work together, and they just presented whatever they thought was really interesting to them. Now, in multivariable calculus, you might argue, wait, what did you have them do? Okay, well, I just wanted them to see some of the research methods. So there was times where, I put up a paper on arXiv, and I was very excited about it, like most of the time we are, right? You get the announcement with your morning coffee, and you're like, yeah, we did that thing. And so one morning, I joined the Zoom call, and I'm like, let me tell you about the math archive. And we pull it up, and I show them all the math that got published in combinatorics that day. And it was eye-opening to them. Like, they didn't know that there was all these people all over the world working on topics just in combinatorics, and all these these very long list of math papers. And so one of the students, I think maybe 2-3 days later, came back to the class and said, Professor Harris, can I tell everybody something? And I was like, what's going on, Michael? And then he said, I was curious if in multivariable calculus there's a version of L'Hopital's rule. Insert sheer panic on my face. I don't know. And he said, I found a paper on arXiv. And so all of a sudden, Michael asks if they can go into a breakout room, whoever wants to go with them, to try to figure out what the heck this, L'Hopital's rule for multivariable calculus is. And then at the end of the class, they came back and they had worked out some of the details, but it was kind of complicated. But that's what they did. It was all of a sudden, like their own curiosity led them to find some mathematics that then they brought to other people. Also in that class, I once showed them parking functions. If you know anything about me, you won't be around me more than 2 minutes before I say to you something about parking functions. And so I told the students about parking functions, and 3 of them came back and they said, oh, this is so fun. Has anybody ever worked on this version of things? And I was like, no. And then they said, can we do it? And I was like, yeah, of course. And so they, again, multivariable calculus students, they learned how to code a little bit, they get some data, they don't know how to prove, technically the result, but they kind of have intuition. And so they write a little bit about it and they create this project that then the MSRI Up 2021 students took on, and they all published this paper that relates parking functions to the Tower of Hanoi games. And then later on, one of those students became a math calculus TA. Now she's an econ master's student in Europe. And then another one wanted to do a thesis and now has 2 other papers with me on parking function related things. And so I get it wrong though. I do so many things wrong all of the time. And I wanted to just admit it because I'm hoping that there's some public accountability for me. One of the things that I struggle a lot with is this collaborative teamwork. I think I kind of can read students and think I can place this one with this one and they'll get along and it'll be great. And then somehow, again, because math culture shows up and I think faster than you, and I'm just gonna tell you that you're dumb. Well, yeah, that's obvious. And all of a sudden, the collaboration that was supposed to spark joy and fun, and somebody's traumatized, and I didn't prevent it. So this is the thing that continues to weigh heavily on me every time that I do this. And so I've done stuff, like I've implemented community agreements, we talk about how to treat one another, it still falls short. There's also this, when you embed it in the courses, people are like, but what about grades? And then I'm like, the points don't matter, everybody gets A's. They don't seem to believe me. And so then I have to make them think about what they contributed, which is great. We should be talking about, the ethics of research. What did you contribute to this math paper? And then they evaluate themselves and their peers. And then this article has been very helpful to me, so turning student groups into effective teams. They actually have those self-evaluations in the end, and their peer evaluations, and a way to use that to hopefully adjust grades accordingly. And so you don't have to give everybody a B when, it was clear that one student kind of carried the team. But I feel like moving forward, I really need my students to learn about what it means to work with other people. And so I think we might need to go into like psychology literature, more educational literature, to learn why we fall prey to being nasty to one another when we're under high levels of stress and trying to learn something difficult. All right, okay, fine, I told you what I do really bad, but let me tell you what I do really well. Feedback. And of course, this is a trauma response. Absolute sheer trauma response, because no one gave me feedback as a student. I remember saying, oh, okay, like I proved something, and they were like, oh, that's great. And I was like, well, can you read it? Like, what if it's wrong? And they're like, what do you mean you don't know if your proof is wrong? And I was like, well, but what if it's written really poorly? What if, like, can somebody read my stuff, please? And I don't think in my life anybody has ever done this for me, honestly. Oh, okay, maybe now colleagues are much better. They just make the changes directly, because they're like, it's too long to tell you how terrible you write. But I try to do this for students, and so absolutely time consuming, but very, very worth it. And in fact, I've moved from this, and sometimes if my students are away, one of the things that is very helpful is sending them videos. So they'll catch me reading things out loud, because that's what I do, right? Like I'll read the thing out loud, and then I'm like, what? And then they were missing that feedback, and now I can annotate and do the recording. But I hope you don't get discouraged by looking at the time marker. Look away, don't look at that part of the slide. Okay, so like I said, I've also done research courses, both at the undergraduate and graduate level, and the point is to just really focus on the research methods and trying to develop a research idea and see it from start all the way to publication, sometimes years later. And sometimes they experience really terrible referee reports. And so we have to talk about, again, the behavior of our colleagues in the profession that sometimes is extremely discouraging, sometimes even sexist. Okay, so here's an example of that. So the students collaborated on a project in combinatorics. It was all collaborative writing, so they would all bring their laptops, we would sit in a circle, and we would edit each other's work. And then we focused a lot on presentations. So I realized that that group of students had never been pulled aside and said, here's how you read a math paper, right? Here's how you do a presentation. What do you mean? What is those slides with the text blocks, which you probably have seen a few from me already, that you're not supposed to do. So we practiced. And now they had slides and then later a poster. And so there's Jan and Kim getting, you see how happy they are? Like, I love this picture. They're so happy going to present their parking function research at a conference in Chicago. And so the thing that I want to impart on you is that you have to start doing this, okay? Maybe you don't go all the way to do a research course immediately, but how do you start embedding all of this? You start small. You tell them about the math archive. You tell them about your research. You tell them about math conferences. Your students don't know that that's a thing. And they're gonna be like, you go to where? To do what? Right, like they don't know this. We have to stop assuming that students just know. And then also just assign things for them to read. Ask them what they're interested in, show them that math is alive and thriving. And then, start small, build some projects, get them to think about how they collaborate with each other. And then maybe even when you don't feel ready or capable, just like build research courses anyways. You'll learn along with them. Okay, so here's what I want us to do. I want us to co-create a mathematics research methods course. How are we on time, Michael? What time do we end? Excellent, all the time I want. Okay, so let me tell you about San Francisco State University. This is why they're amazing, among many, many, many reasons. But they actually teach a course that is sort of the basis for what I envision, but I think we can add more to it. And so that's our goal. So here's what they do. They do oral presentations. They do a poster presentation. Look at that third bullet. They write a grant proposal with their master's students. I'm doing this like as a one-off, wherever I can scrape a little bit of time with my students to try to write grant proposals, but for them, this is in their class. And then they write an expository paper that then they use as the first chapter for a thesis in their second year as a graduate student. And then they do substantial edits to a Wikipedia page. Now, when I look at the things that Simmer, one of these Center for Improvement of Mentored Experience in Research, they claim that we should be addressing these 7 areas of development for students. So research comprehension, communication skills, practical research skills, research ethics, researcher identity. Why is it that our students feel like they're not a mathematician? We should be having conversations about that. And how do we build positive experiences so they build that identity? And then research confidence, independence, of course, equity and inclusion awareness and skills, and then professional career development skills. So here's what I want you to do. Pull up your phone, go to this, pick a column, and tell me something you would add to this course. What do you add to this course? And you should be able to scroll right. There should be at the bottom of your screen a plus button. You press the plus button either under the column, and then you should be able to start typing. How are we doing? Everybody okay? Anybody need help? A neighbor might be able to help. Okay, I'm gonna switch over to that if everybody has done that already. Awesome, it's working. Oh, searching skills with librarians using MathSciNet, Archive. Ooh, that's amazing. Images and copyright issues. Yes, how to use MathSciNet, how to subscribe to Archive, good peer review culture. We have to talk about that because they are the future reviewers of these articles. So we should absolutely be talking with our students about how to write proper reviews. Maybe how not to let AI do it all for you. Learning when to draw the line with work colleagues. I agree. Who gets to author a paper? Okay, let's look. Professional career. How to type math. How to make connections and build a community. How to put together job materials, job timeline, career options. How to give good feedback, absolutely. Under research confidence and independence. Building more presentation skills. Meeting researchers, maybe via Zoom with different identities. Have students give compliments to others during feedback. I love that one. this will be there for you. So you can start building your own class. And I think this is stuff that we do almost always one-on-one. But guess what happens when you do it one-on-one? The accessibility issue shows up again, right? So not everyone that needs this feedback, that needs to hear these things, gets access to it. Okay, for sake of time, let me escape out of that and go back here. Please continue typing, sharing anything that you want to share. And let me tell you a little bit about, just again, this math culture thing, which I think for me is the part that I find the most problematic. So first off, just some definitions. When I say the words mathematics community of practice, I think of a group of people who have the shared interest in mathematics who work together to improve together. And then when I think of the culture of mathematics, this is the way that we induct students into our community of practice. And then when I think about mathematical culture, this is the environment in which we're all learning and we're all working together. So it's how we encounter the mathematics that we're learning. And then it influences who we let into that community, okay? And, escape was the wrong button, but that's okay. We do that. Here's a quote that just feels like it hits me in the gut every time I read it. So Dr. Leon Burton, passed in 2007, phenomenal math education researcher. She has this quote, it says, "It is the mathematical culture that creates barriers to entry by members of certain groups and facilitates others. It is the mathematical culture that must be addressed if mathematics is to achieve widespread accessibility." It's the culture that is the problem. It is the culture that excludes people, that waits, and you have to have a Zoom meeting with one student because the culture has told them that they shouldn't go to graduate school. And that is what we need to change. That it can't be luck anymore. It can't be that we happen to be on that Zoom call and I ask you, when are you applying? That can't be the case anymore. So, yes, you can integrate research and teaching via research opportunities and create these beautiful research methods courses, but if you don't focus on accessibility and stop pretending that you're only letting some people in and others you're actively keeping out, then is that the math community you want to be a part of? And when I think about how we fix this, well, I feel like the first step is that we need to really challenge these myths that continue to divide us, that continue to make us think that the thing that we love and spend a lot of time on, like teaching, is not valuable. We need to then change the culture of mathematics so that it is focused on accessibility, inclusivity, and feeling welcomed. And so I want you to help me. Please help me. And all these graduate students that are here, like you are the change that is needed in this beautiful discipline. And I hope that you value research and teaching and education on equal footing. So I'll end with that. Thank you so much.